first of all, Frank, it's a pleasure to have you here. When the last time in Poland, 2 years, 3 years ago?
I think so.
4 years, I don't remember.
I think before COVID even.
It was before COVID, I think. Because after that, DEMCAM came for VMware. Everything is blurry, definitely. That's the story. Everybody, this is EvoilutionCast. My name is Maciej Lelusz. Today with me is Frank Denneman. I'm sitting in his shadow today. Many years in VMware. How many years are you sitting in VMware and / Broadcom?
In total, more than 12. But I had a brief stint with a VMware ecosystem startup. So it was 3 years at a startup, back to VMware, and now I'm in my 8th year, actually hitting 9 in October or something like that.
Cool. Yeah. Cool. 12 years. So you see the all phases of that, right? The products, going out products, the Broadcom acquisition, everything there.
I think I saw every CEO except Diane, but due to the fact that I was working within the community at 2005 already, basically installing ESXi and going from there. So I've been to my first VMworld was 2006. Yeah, and I've been to TSX in Europe. So I've seen all CEOs up to now. Yeah, fair enough.
That's good. It's good. Good background. What I want to talk with you about is obviously AI, because nobody's talking about anything else. But let's cut out this, more or less bullshit sometimes, stories about how it will change our world, blah, blah, blah. No. The thing is, because we know each other so many years, we are more, let's say, we are not people who talk about theory, right? We're more practical guys. And I think that that's the way how we should talk about technology right now, especially AI, because if you see this magical stuff that it can do, basically, you stop to thinking about real use cases because it's so fancy with this super easy access, all these pictures with Gibby, or these action figures and sales guys on LinkedIn. It's just easy to digest content. But in my opinion, there's this is just a facade, right? Just to make this technology not scary, right? For normal people, let's say. But behind that facade, there are real use cases, right? And why I bring you here today, why I ask you to join us is we have VMware AI with nvidia, right? So could you tell about it a little bit, for Polish folks?
Yeah.
Because it can be everything, it's not precisely what it can be.
Yes, well, that's the concept. However, when we started to develop this platform, so it's built on top of the VCF platform, we started to think, okay, if we look at the AI ecosystem, the broad landscape, it's very wide, it's also very deep, and it's changing almost on a day-to-day basis, right? Look at the models coming out. It is like tremendously fast, right? Exactly. So can you create a platform for the customer base that we have to be like everything? No, you can't, right? That's simply not doable. The other thing is, and that's more strategy than use cases, we and other people say this as well, don't go try to solve everything. Figure out a particular use case that you have that you want to solve and start there. Don't go wide and try to paint everything AI, right? You won't be able to do so. Funny thing is, if you look at the energy and if you look at the AI, the compute power and the resources that you need to have, there is not enough power and AI resources for every customer in this world to do it at scale. that's simply not there, right? And if you start to understand that, then it's interesting. Like, okay, let's design our strategy to solve some of these things, and then basically move on slowly. So we build before we basically go into the use cases, we build a platform that looks at what do you need. You need to have your data, right? Now most of the enterprise data is already stored or running on VCF or accessible through VCF, so that's seriously a big plus. So the thing that we need to do next is expose the hardware, make sure that you can use the hardware like the GPU accelerators, the GPU devices, as efficiently as possible, and also make sure that we can do this in an easy way. The abstraction layer that we typically provide with normal compute and normal storage and normal network, do the same thing for GPUs. And then, of course, try to go beyond the typical layer that you're used to with VMware. So we had always inside research and development, we had this rule that you never cross the boundary into the virtual machine. We never did that. So it's always the VM, and then the rest is up to the customer, right? So think about, you want to run a database, fine.
So it's like a pure infra. Pure
Exactly.
infra?
Yeah, exactly. Right? Yeah. Because there is this privacy boundary, there is this you don't want to be an opinionated boundary and all that stuff. But for
So
Private AI
basically,
Foundation,
you act like a little bit like a local hypervisor, right? Because we have this two sides of the hypervisor responsibility matrix, right? The hypervisor, let's say, it's responsible to the infra, and from the infra till the, let's say, application layer and so on, their customer. And I think it fits pretty well with the VCF9 concept, generally the VCF concept, that you build your private cloud experience, right? So you, as an infrastructure provider, gives to the users that consume that infrastructure rigid platform, right? It's not something like, they're going to be glued with the duct tape stuff. No, it's a solid structure that gives you access to API or other ways of consume that to the users. And what the user is doing with that, you basically maybe not don't care, but less care than because you are infrastructure provider, right? So that's my point. That's what he said. So it's VCF. So there is a hardware basically on top of that sitting VCF, and on top of that you have the AI platform, right?
Yes, but for the first time, we actually moved into the VM or moved into the container runtime, because we said, let's be somewhat opinionated to give a easy method to get started with some of your AI use cases. So instead of saying, oh, here's a platform, and now you basically have to find out everything yourself, we said, no, we're going to help you along the way. We're not going to like build everything, because we have a very strong ecosystem with a lot of partners, but we will give you enough functionality to make your first steps, right? So in essence, what we do with Private AI Foundation is we focus on what's called Retrieval Augmented Generation. I will talk a little bit more detail, I assume, a little bit later. But the idea is that if we can do that very well using external data from the model, and then basically getting into a solution, then customers are already helpful like 80%. And then if you need to swap anything out, or if you want to add more, you fine, right?
So to sum it up, like to rephrase it, if I understand it well. So on top of this infrastructure that is organized by VCF, you build you can think about it as a customer, as a SaaS solution, but running inside your infrastructure, that you can do some stuff from the package out of the box, right?
Yep.
And eventually pivot from there to some more sophisticated solution, because the infrastructure is there, right? And it's an easy starter, solving maybe not the corner cases, but 80% of the general cases. And then from that, if you learn and understand for what you need that AI, not only for creating a Ghibli-like, Studio Ghibli-like pictures, but some real case scenario, then you can pivot from there, right? Something like this?
Correct. No, that's perfect. Yeah, that's a perfect summary. And so what we also do is we figured out, okay, if you look at it like a spectrum of services. So at one hand, we have what's called a build your own. So we give you what's called a deep learning virtual machine and a AI Kubernetes cluster, and that's a pure basis for you to consume the GPU. So it's a very rudimentary, very simple GPU as a service. Now, I do this because I believe in most cases for data scientists or for developers, that's not a service, it's more of like a disservice because a modern developer and a modern data scientist, they say, give me my preferred um, interactive development environment, my IDE, right? That's a Jupyter Notebook or a VS Code or whatever, right? But what we do with at the end of the build it your own spectrum, the DLVM and the AI Kubernetes clusters, is we give you enough resources that's aligned with the technology stack. So to go a little bit more into detail, if you build a virtual machine or a Kubernetes environment with a container runtime, you need to be aware of the driver, the GPU driver, because there are a lot of libraries that are reliant on a particular version of that driver, and additional libraries and additional elements such as Python or a particular other library needs to be aligned with a specific CUDA version, the library set of NVIDIA. Now, what we thought about or what we delivered is a DLVM that we recognize the version of the GPU driver in the hypervisor. We align it with the driver in the VM, and then we provide you with a subset of libraries that are aligned to that driver version in that virtual machine. So that it's a very brittle stack, but we
So
already
it's
solved
like a
that for you.
safe. It's like a
Yes.
safe place to start your
Yes.
journey,
Yes.
and
Perfect.
then go for more sophisticated, let's say, use if you need them, because
Yes.
when you look in the market, the standards, because 2 years ago there were no standard, right? Right now we see slowly that some of the libraries, some of the environments getting in speed, right? So people choose them more often. Let's say TensorFlow, right, or stuff like that. We see that it is more popular, right? And so you took this, built a platform for engineers, for developers, right?
Yes.
Yeah. What is doing this platform?
Yeah. So I think that's a good thing that you let's move on to that use case, because you said something. You said it's a safe place. Now let's take the use case of that DLVM or that cage cluster, that AI cage cluster. So typically, what happens if we look at the use cases or the workflow of a data scientist? Most customers right now, they don't build their own model. They get what's called a foundation model, a pre-trained model from an online repository. So one of the most popular ones, a US-based
Okay,
one,
Hugging
is
Face.
yeah. So Hugging Face is the repository. It's like the GitHub for models. And so you can download like Llama, the one from Meta, the foundation model from Meta. Now, that means that you have a large language model that's already pre-trained with a lot of knowledge, with a lot of data. Or you can use Mistral's or Mixtral's, one of the European models. Or you can go to China and you can take a look at DeepSeek or whatever, right? But the interesting thing is, we typically lean on somebody else's work in the data science community. And then basically we figure out, how can I improve it for my own use case? Now, if you download a model right now, the last thing that you want to do is just instantly put it in production. You have to make sure that that model is actually promising what it tells it that it does. You need to figure out, okay, what are the heuristic, what is the behavior of this model, and are there any security holes, whatever. So with that DLVM, what we do is we provide you with the ability just to spin that up using automation, because we already have these templates available. So there's a self-service portal for the data scientist. Spin it up, they can download that model into that
Okay.
PLVM, and it becomes like a clean room, right? Then you can use your tools, your security tools, your baselines, all of these tools that allows a data scientist and a security officer to figure out, okay, is this a model that we think is acceptable for our organizational standards? If that model has got the green light, then we go on to the next step, and that is a model gallery. That's Harbor, what we use, and we use that to basically provide a like local Hugging Face type repository.
All right.
So what we do is we package that model as a OCI compliant Kubernetes image. And so you can store it in a project, in a system that you can apply role-based access to. So some of your models can be like, okay, this is the available models for the entire organization, and everybody can access that particular project. That exactly right. And so to give you another example, let's say a organization says, okay, this foundation model is great, but it lacks particular organizational knowledge. Let's fine tune it. So let's fine tune it with our HR data. Now, the last thing that you want to do is have that model accessible for everybody, like for all the developers, for all the data scientists.
Exactly. What is the CEO salary, please?
Yeah, exactly, right?
Your
All of
model.
that.
Yeah, here
Yeah,
it is.
exactly.
Bam, 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 bam.
Yeah, so you store that in that project. You basically allow only a subset of data scientists or developers to access that repository, and then you make sure that, hey, we can keep it safe, all while still being localized. Now, one of the key things, there are multiple good things about this. So first of all, models are extremely large. Like the real easy way to think about it, typically a model, you basically specify it with a parameter count. So when we say it's a 𝓛𝓲𝓼𝓽, then we say 8 billion or 33 billion or 405 billion. That's the parameter count. Every parameter typically takes up 2 bytes. So basically, a billion byte is a gigabyte. So from a storage perspective, a model of, let's say, 405 billion, which is kind of large for an enterprise, by the way, takes up more than 800 gigs. Now, 800 gigs is not that much if you have it once, but if every data scientist in your organization is going to download it locally or store it on a NFS share or whatever, you're going to burn through storage really, really fast, right? Because you have all these redundant copies, and you might not have a very eloquent storage system that basically says, oh, I've got a lot of deduplication.
Like deduplicated, right?
Exactly, right? So by storing it into the model gallery, you also make sure that, hey, first of all, these are the models in play. These are the models that we verified. It saves a lot of storage. And the cool part is it's local. So when you want to run such a model, you specify the local repository. So the spin up time for a model, getting it from storage into GPU memory, is much shorter, right? That can help with scaling, and we can go into that as well. Now, if we go beyond if we then say, okay, we've got a model, we make sure it's secure, it's safe, it's green lighted. Now, the next thing that you want to do is you want to run it. Now, you can do 2 things. You can deploy that AI Cage cluster and basically install all the serving frameworks and all that stuff. But we have in Private AI Foundation, we have model runtime. So with the use of a CLI, of a UI, a data scientist or developer says, okay, give me a model endpoint. So the only thing that they need to do is specify the model, basically where is it in the model gallery, what's my infrastructure like. So we provide with VM classes like, this is GPU, this is the amount of replicas, this is CPU, and this is memory, and that's it. And then basically you say, okay, please deploy this model. So we deploy a Kubernetes worker node with all the libraries
that cluster.
Yes, on that cluster, on that GPU, on that host in the most efficient way. So we basically automate everything as efficiently as possible. And the only thing that comes back to the developer in the CLI or in the UI is the model API endpoint, which they can use and then basically
build
say,
up.
okay, yeah. So they can say, I'm going to use that in my application. But another thing what you can do, if you think about it, because there's a lack of GPUs mostly in enterprises, is you say, I'm going to spin up some Jupyter Notebook DLVMs, and instead of loading a model directly into that DLVM, I'm going to use the model runtime endpoint, right? So if you have like a collaboration going on, like 5 data scientists trying to figure out what that model is doing, you spin it up in the model runtime, and every Jupyter Notebook environment just runs on a CPU, but hits that model at that model endpoint who consumes a GPU. That's a far more efficient way of dealing with it while you still have everything local, right? You don't do that for production, of course.
And tell me one
Yep.
thing here,
Yep.
because I see this pipeline, that is
Yep.
going in, there, another, this person can use it, this how we can collaborate on that stuff, that's pretty amazing. But, usually those infrastructures are extremely expensive because of the equipment, GPUs. Generally speaking, it's not the cheapest hobby, let's say. And
Nope.
do we have any option in VCF plus private AI with NVIDIA have some kind of tracking of spendings, billing, something that it's allow organizations to basically tell to their users, hey, maybe, 5 models in the same time when you don't use them, cost you too much, just some kind of limit the consumption. Because you know how it is. When you have it for free, you use it without thinking.
Yes. There are some constructs that we offer. However, I think most of the stuff that you're talking to is still on the roadmap. So it's more like FinUps, right? It's like figuring out, okay, I've got these models running. What's the dollar cost or the euro cost per inference or per token or whatever, right? Now we do have an API gateway in the model runtime, allowing us to understand what are the requests coming in, which model is it hitting, and so one of the things that we're thinking about, I'm not saying it's going to be the next version, so this is not a promise. I need to make sure that that's the case, but we are thinking about, okay, can we somehow do a quality of service on tokens, and with VCF ops, can we monitor that, and can we provide like a cost tracking ability, saying this model is very expensive because you're consuming, let's say, an H100 or a B200, a newer version of GPU, $40,000 US, but it's not hitting any ops, right? It's not actually getting any token request. So that's a very expensive thing, right? Because one of the problems what we have within the whole AI world is that you cannot oversubscribe a GPU.
So basically, you use one,
Yeah,
one, and that's all, right?
exactly,
Yeah.
right. So you have to figure a different way of exposing the GPU or the model, the consuming factor, and then see, okay, what other services can I allow to consume that? So the key thing, what most customers are now understanding, is that there's no one-to-one relationship. What I mean by that is when you deploy an application, you hit it, you basically connect it to a model API endpoint, to a model running on a or multiple GPUs, but that's not the only application that actually hits that model endpoint. Multiple applications can use that same
You
model,
can use the one model.
unless,
Yeah.
yeah, exactly, right. Unless you have very, very specific categorized data, and then you can solve that also differently with different models, different way of exposing particular data. And then we go actually in the most common use case that we see right now, and that's called retrieval augmented generation. And an easy way of saying is, I want to use natural language to talk to my organizational data. So to give you an example, if we take like a legal firm, and they're in their discovery phase of a particular case. What they do is they digitize all documents and expose that in a way, and I'll come to that later, to the large language model. And so customers, or sorry, not customers, but particular legal personas, they can use that application to directly talk to the documents and ask specific questions. Like, okay, what's going on with this? Can you find any relationship with that, or whatever? And that's the nature of having a large language model, the intelligence of a large language model, but also having directly access to your data, to your personalized data that you don't want to basically
share anywhere.
Yeah, share anywhere outside of your organizational walls, or maybe even on the internet, right? So another way what you can think of is coding assistant. A great example is our own environment. We downloaded a coding assistant from Hugging Face, and we fine-tuned it. So fine-tuning is basically a shorter training period with less amount of, or fewer amount of data, to basically extend that model with some additional knowledge. So you're basically extending its wisdom, right? And so we highlighted our 10x coders. What type of code have they delivered to the core code of the hypervisor and all of our other core elements? And we use that as a data set to fine tune that coding assistant. And now the majority of our developers are getting access to those 10x coding ideas. Like, okay, this is the structure, how you typically do. Now, if you look at that data set, that is literally our core IP, because it's the source code of the
Yeah, of
hypervisor.
course.
We're not going to upload that to AWS or to Google or to Microsoft or wherever, right? So you want to do that in-house. You're right. So, and that's our example. But there are so many customers out there that says either we're not comfortable, or we're not allowed to, due to regulations, due to particular adherence to certain EU rules or something else, right? And that's the idea. So what we do is, when we go into retrieval augmented generation, we have that foundation model. So typically a llama or whatever. And then next to that is you build what's called a vector database. And that vector database can be deployed by our DSM. It's a data service manager. It's a self-service portal to deploy a vector database. And we connect that vector database to the large language model. Now, the data that you have, you're going to embed that into your vector database. So there's what's called an ingestion pipeline. I will talk about that a little bit later, how to automate that. And so every night or something, you're going to scrape your data sources, and you're going to feed the new data into that vector database. The moment you have that in your vector database is the moment you can access it. So to give you a great use case, we have a lot of telco providers and a lot of financial institutions that offer new types of services on a regular basis. Now, when you call up like a call center, you will get, after basically going through all these automated steps, you will get a real person, and you talk to a real person, because that's what most people like. If you ask a question nowadays, they have to go and find their information in typically one of the 6 screens or 9 screens that they have in front of them, right? So they have to figure out, okay, which screen do I need to access? Which application do I need to do? And while they're talking to a customer. Now, what some of these organizations have done is they said, let's grab all of that data and give that large language model access to that data. So the moment a customer asks a particular question, the support center agent or person basically can type in that question, and the system will look for an answer and will give back answers with a particular source. Like, I found your answer in this document, so it immediately can validate whether that. Exactly, right? And so that's a very human way of enhancing the human conversation. So instead of
Sounds like a
exposing,
augmentation for the
yes,
person, right? Okay,
exactly.
let's not look into the normal search, type it in, blah blah blah, but just go through the results instead of searching
Exactly.
for the data.
But the reality is that instead of thinking about, okay, how can I expose my AI platform to my own customers? No, I'm going to give it to my own personnel that allows them to respond in a more human way, in a faster way, in a more efficient way, right? And then you can basically go ahead and say, okay, hold on, why is he or she still typing? Let me basically do multimodal, meaning that when a customer is asking the question by voice, we'll basically transcribe that voice question into the system, and we automatically go and try to fetch the answer. So the person basically don't even have to type, can basically be alert, can basically be engaging with the customer, and basically say, okay, I just looked at it, this is what the system comes back. So that's one thing. But the cool thing is, every time when you have a new service or a new product or whatever, you instantly feed it into the vector database. And from the moment it's in the vector database and you ask it a question, it's retrievable. If you compare that to fine-tuning, you need to basically get the data set, prepare the data set, fine-tune the model, train the model, understand
One
whether, or
data
test the
set.
model whether it exactly give you the right answer, and then you have to replace the model, right? It works for really static data. That's not basically replaced often, but for fast,
Live fast
yeah,
feedback.
that's the way to go, right? And so we see this use case playing out over and over and over with most of our customers. I want to engage with my data, but with a natural language. I want to ask
I
questions.
got you.
Fraud detection, same thing. Go ahead.
The question here is, because we always tell about the story behind how to use this technology, but in real case scenario, we get the law firm, we get this support center use case. What else do you see in the market that right now are trending? Like a real case, access to the
Yep.
lawyer data, I understand the support as well. What is there as well?
So we had an interesting use case in the US where we heard that there are a lot of surgeons uh, they are on the brink of a burnout because of
Mm-hmm.
the heavy administrative load they're facing. So when you're a specialist, you basically operate, but you also have to talk to your patients, and you have to figure out, okay, what's wrong, what's my plan of getting you better or getting you into a better shape than you are now. And so what happens is most of these conversations, the the surgeon or the specialist, they are going through a particular questionnaire, and then they have to listen, and then they have to write it out, they have to feed it into the system, and then they go from there, next to their already extreme workload of doing surgery and all of that stuff. So there is this use case where, with, of course, the approval of the patient in the room, the system listens to the
What
conversation.
are you
So
talking about?
the surgeon, yeah, the surgeon is asking the questions from the questionnaire, and it transcribes that conversation. It immediately fills out the questionnaire. So after the conversation, the surgeon only needs to check whether that's accurate, and then basically submit it to the system. It reduces the workload so much that it saves them from that burnout. It's not the only one of saving for the burnout, but the reduction of that trivial work, yeah, that's a good one. Um, Another one that we see is the combination of machine learning and Gen AI. So machine learning is basically understanding logs, understanding particular patterns, doing some math, and then figure out what's going on. So another use case that we saw was fraud detection, that we um, there's a particular transaction and that's flagged. Right now, that specialist, that analyst, need to go into the system and understand why it's flagged. With a Gen AI system, they can basically say, okay,
So summary.
give me a summary why why the
Mm.
system flagged this. It's a better way. And overall, here's the thing, right? Gen AI won't replace jobs, or the majority of jobs won't be replaced by Gen AI, but you will be replaced by somebody who's using Gen AI. So it's a faster way. It's an efficient way of doing your job, cutting particular trivial things, or making or helping you. Like what you said, it's the augmented fashion, right? It's a way to get better results easier. Same with the coding assistant. You see a lot of engineering depending on, not depending, they're they're being helped by the coding assistant. The coding assistant won't write you code, but it will give you structure. It will give you hints in order to code faster. And those are the use cases that we are are relevant
So
and actually,
yeah.
yeah, go ahead.
So basically, I think it could be a take. The people can take out from this conversation that if you have your process, no matter the process where in what kind of part of your organization is, you should look on the things that are toil for the people, that basically doesn't make their job, you know, more interesting, more meaning something. So you take this maybe not meaningful, but kind of things that is a toil for people, and to try to automate them, because some of them, like filling up the blanks, right, or looking into the connections between the events, can be at least summarized by AI, right? It's not about making decision in AI and put AI on entire process, but just to augment the person work, to be focused more about that what is important, like the surgeon, right?
Yep.
He needs to save people's lives and not basically fill the papers, right?
Yep.
And I think that a lot of specialists are like that. Do you remember from engineering teams that I was running back in the days? They hate this, the tickets and everything, this paperwork. They will give everything that AI will fill the tickets after that with the standard reply or wherever, or I'll tell them like, hey, this is the pattern. The guy is doing it every 3 weeks. Just click and that, and it will solve the problem, because it's the last 5 years the same situation. So if we take any basically industry and any business inside them, we take the process, we uh, look at the process and see that there are things that not necessarily human needs to do, but human should approve, right? Something
Right.
like that. It could be like take out. I'm really interested about more of that, but as well, I'm very interested, like if you tune this model, right? Then we understand, basically replace the brain, right? We replace the model with the new one. But you start to talk about a little bit different approach, that you do it, let's say, to get the faster feedback. So you get the ingestion data, you move that, you build a vector database to have this fast access to the data. How to streamline that? Because it doesn't sound that easy on the first place. I think you have solution for that as well.
Yeah, with AI, nothing is really easy, but you can make it easier, right? And so
Mm-hmm.
one of the things that we do, so when we're looking at the retrieval augmented generation pipelines, there are actually two. So there's the ingestion pipeline, getting data into the system to be retrieved, and the retrieval pipeline is the other pipeline.
To give it to the
So
customer.
yeah, exactly, right? So basically, to figure out, okay, what knowledge does my system have? Now, you can identify certain steps in the ingestion pipeline: your data source, your framework, your ingestion framework, in what's called an embedding model, and then your vector database. So your embedding model is pretty much a way to to provide context to a particular word and then store it as what's called a vector. So the context-based element in a vector database, so you can do what's called similarity search. To give you a good way of providing similarity search or embedding in general, the most common example, what we typically give is when we talk about Apple. Do we talk about the fruit or the technology company that's competitive to Samsung? Now, based on the cluster that we of words that we're looking into, we can understand context. So if I say Apple and iPad, chances are high probability is that we're not talking about the fruit, right? Yeah, exactly. And so that's how you typically do similarity search. To give you a real example, when you load up FAQs in a vector database, that whole context is typically the question, and you store a question and an answer as a whole in your vector database. So the moment I ask a similar type question, the similarity search is a high probability that your question is matching with that particular answer, right? And so that's the answer that you get back. Now, that pipeline, sorry to go back, I just wanted to talk a little bit about vector database. That pipeline is something that you can build with what's called data and indexing and retrieval system of VMware Private AI Foundation. So we call it internally, we call it RACs. And so that allows you to build that pipeline. Now, the other thing that we provide is what's called an agent builder. And right now, the primary use case of the agent builder is to build that pipeline. That like, okay, these are my data sources, this is my vector database, this is my embedding model, this is my completion model. Go build it, right? And so tie it all together, because you need to have a lot of glue. Those are the elements what we currently offer within Private AI Foundation with NVIDIA. And so with everything, if the data scientists have to figure out, is my data okay? Am I getting the right data? Is it the right quality? Do I need to restructure it? How do I need to enter it into the vector database? And these steps they can tinker with that themselves. We're not too opinionated on that. Make sense?
All right. So entire platform allowing you from, let's say, ingest the data, work on the data, ingest the data to the model that you choose from the safe library, which you have airbag on the back, that not everybody have access everywhere. And then on top of that, you can run the models on the VCF structure, VCF-based infrastructure, right? To consume that by application that I'm inside the organization, right? And different applications built by different people. This is good that it's there, and but when you go beyond that, like there are organizations who work with AI from very beginning, not maybe build their models because they are aware that they are not that big, right? But they're using something that it's there, and they're using it in very proficient way. They can extend the capability of the private AI with NVIDIA from Broadcom to their own needs, like tune it, like use it differently, or it's just like SAP, you just get it like that when it's first time installed and forever.
No, luckily we are open. So one of the key things that we said is we're going to build to a certain level and then expect our partners to step up, to add more value, right? Because we cannot do everything, and the whole ecosystem is too volatile to actually say, hey, where are we going to spend our engineering cycles in the next 2 years? Is it X, Y, or Z? And then basically figure out that we chose X and now the whole world is using Y, right? So we need to be very careful in our strategy and the way we plan things. So because we have this broad ecosystem, why not use it? Why not have the ability to say, okay, we give you the infrastructure, we give you the fast infrastructure, the efficient infrastructure, right? One of the things that we typically hear is that I don't want to use virtualization because there's the virtualization tax of performance. No, there isn't, right? In some cases, there is. However, that's such a corner case that we typically don't see as a true value for our platform. So to give you an example, if you want to build a very, very, very large Gen AI model, we don't believe VCF is the way to go. There are dedicated structures for that. Now, to give you an idea, what am I talking about? When Meta launches a new Llama, they use 2 clusters of each of 24,000 GPUs. They only use 16,000 because they need to swap out the GPUs constantly during the process. They're using 2 different networks to figure out what's fastest, but for that scenario, we don't say, look, build that on VCF. Like, oh, you have a 16,000 GPU cluster or a 24,000 GPU cluster to build large models. No, use VCF. No, use bare metal for that. That's not our use case. But what we focus on is the inference side of things or the fine tuning side of things, right? It's a smaller model or it's a large model, but you just add a few layers to it or you add
Exactly.
some data to it, right?
I think you can connect that with some kind of example. You don't get birth to the person. You generally take this person, go with it to the school. I had this example. Like they build the personality, but you don't want to do it. It's a God's work. It's a lot of extra resources probably, and you need to be almighty. And then when you don't have such a use case, you usually take the person and give him the best education in life that they can get to be the best one, right? And I think that's how we should think about it, because many times with our customers as well, we hear the use cases. Hey, let's build our models. Like, hey guys, I love you, but you not afford. It's just just admit that. Look at those guys. How much they spending, how much energy they consume. Just I'm sorry to sell, but sometimes it's not your league, right? You can take the fruits of their work and tune them, like you said, and then run them on the edge where usually they belong, close to the users. Because you like you said, Guy, I think, Frank, you said that you are focusing VMware in Broadcom on the infrastructure for AI. Because if you will start to be focused on the use cases, like the specific things, you stop to be infrastructure company and you start to be some crazy startups ecosystem for solving everybody's problem, right? And I don't believe that it's a good place to be. It's more like you enable the platform and maybe in the future some marketplace to buy SaaS kind of solution on AI. It means this model GUI and stuff like that to run on private AI with nvidia from Broadcom plus Tanzu platform, right? Because basically this is it. They deliver that in VMs or containers and they use packed models with some tuning, right? Not even very much, to be honest. For many use cases, you just take your data. They are not so much changing. Come on, if you are a law firm, how many times you open new case? Maybe 3 times a day, 4 times a day. It's not like 300,000 times. If you are, then call me. For sure, I will find a solution. Don't worry. But nevertheless, it's about the fact that we usually have smaller needs that we expect on the very beginning, and we don't need to create something new. Just pick up the best fruit that's there, use towards your data, check the process where is the toil for the people, and then if you introduce the AI solution on top of that, this is really something that it will change their life. Because if you just give them a tool to generate lovely images, it's going to be fun for 5 minutes. Everybody will talk about it on LinkedIn, YouTube, and blah, 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 but nobody really cares in the end.
No.
I think that I understand the process. I understand the value, some use cases as well. What's the next steps, Frank? What is in your mind right now on top of that?
So I want to add something more to what you stated because I'm 100% aligned with what you said. Another thing is when you say introduce toil, and you basically said let's pick a low-hanging fruit, good fruit but low-hanging. The idea of that is you have to go through the motions as an organization, because once you deployed that solution, you're not done, because you have to figure out how is it used, how do we scale, what are the patterns of the user itself, is it like a linear growth or is it a hockey stick growth, what happens with maintenance, all of these stuff. And to start with, like a simple example is a good way of understanding how you expose that service internally, right? And then you can grow and you can add more of these services. And typically the quick wins typically help a lot and save a lot of money, or it's either saving money or it's making money, right? But these are the things. Now for the next steps, we just I think we created a really good foundation with infrastructure consumption, infrastructure management, but also a little bit of an additional layer that goes
Mm-hmm.
beyond the VM
Like
boundary.
CI/CD, right?
Yeah. So
That's
the private AI services like the model runtime, the model gallery, data index and retrieval, and the agent builder. And now for us, I believe it's the next step of providing more integration or lateral integration, more additional and easier ways of consuming this, right? And of course, we're going to figure out to improve infrastructure consumption. We're going to improve monitoring and observability and security, of course, right?
and
But
billing
I think, sorry, and
and
billing,
billing.
yes, right? Yeah, because look, like I said in the beginning, you're not going we're not, in this world we don't have enough energy and resources to do AI at scale for every company. So we need to figure out a way to give you the best way of consuming the resources that you have. How can you do that in the most efficient way, and how can you make your own organization successful? And that's our goal.
Good to hear that, Frank. I really appreciate what you're doing there because you're bringing the AI construct generally to the data center when for many companies it belongs from the very beginning. Because, like you said, not always sending your data somewhere that it's not entirely under your control make you feel very comfortable. I really appreciate that. And as usual, it's a pleasure to have you here. And I hope we'll see each other soon.
Yeah.
Thank you very much, Frank. It was a
Thank
pleasure.
you for having me. Thank you.